Hello and welcome to today's video. In this video, I'll be making a gripper for a robot arm using the gripper from the BCN 3D Moveo robot, which is a 3D printed open source robot. I'll be modeling this gripper in MuJoCo. If you're interested in using this robot, there's a dedicated GitHub page for the project where you can download the CAD files. I'll be using the CAD files specifically for the gripper. I plan to show, step by step, how to model the complete BCN 3D robot in MuJoCo, starting with the gripper. So make sure to subscribe now to be the first to know when I publish the next videos. Before we start, I'd like to explain a few things. In a previous video, I showed how to use STL files, but didn't go in depth into creating collision surfaces. So, in this video, I'll cover that. For example, here's one of the gripper parts, the gear. Normally, you'd export this as an STL file. But for collision purposes, you need to create and export only the surfaces you want to use as collisions. I've already isolated and exported those surfaces separately. Now, in this directory, I have all the collision surfaces for the four parts of the gripper: the gears, pivot, and the cover plates. For the cover plates, there are no collision surfaces, only the mesh itself. Let's begin. I already have an XML file prepared for the model. I'll walk you through it. As usual, we start with the MuJoCo tag. Then, I specify where the meshes are located, as shown in the previous video. I start by importing the assets, beginning with the main gear for visualization, and then the corresponding collision meshes. There are two gears, an idle gear and a servo gear, which connects to the servo motor. There's also a pivot arm, the grippers, and the cover plates. The pivot doesn't need collision, the gripper does. Now that all meshes are imported, let's drop this into MuJoCo. When I open it up, the model is empty because I haven't added anything yet. Let's add the floor, which will just be a flat plane. After reloading, you'll see the floor in the environment. Next, we'll add a main body called gripper, which will encapsulate all the parts. This helps us reference everything more easily later on. Let's add the idle gear mesh. After loading it in MuJoCo,
Whoa, it's huge.
as mentioned in the last video, we need to scale it down. I'll also import its collision mesh. Now we don't see much change visually because the visual and collision meshes look the same, and I've disabled collision for the main mesh. To fix the scaling, MuJoCo allows us to define defaults. Since I want to apply the same scale to all meshes, I define a general default without any class name and set the scale factor scale equals 0.001. Reloading in MuJoCo, now everything is aligned properly. You can now see the frame, but I don't like where it's located. I want the z-axis to point in a specific direction. Again, defaults help. I'll define a class for the idle gear, set the desired POS, Euler, color, and a mass of 0. Now when I reload, the gear is properly aligned at the rotation point. It wasn't perfect initially, but now it's fixed. Next, I import the servo gear and its collision mesh. I define a class for it as well and set its orientation and position based on the assembly diagram. Reload. Now the body is in the correct position. I then add joints to both gears so they can rotate. Because the center of rotation is at 0, 0, 0, I define joints there. Reloading in MuJoCo, Perfect, they can now move. Next, I import the pivots, both left and right. These don't require collisions. I also define their joints and reload. Now for the grippers. Each gripper has a visual and collision mesh. I import both sides and set their orientations via classes. Reload, everything is in place. Now comes the tricky part, linking the grippers to the pivot arms and gears. MuJoCo only supports a tree structure, so I can't directly connect both the gear and pivot arm to the gripper. To solve this, I use constraints, specifically the connect constraint. But connect needs sites, which are reference points. So, I define sites at the connection points on both grippers and pivots. After defining the sites, here they are. I then add the connect constraint. On reload, nothing happens. That's because the gripper is fixed. I need to make it movable by adding 3 sliding joints, X, Y, Z, so that MuJoCo can align them automatically. Once joints are added and I reload, boom, they snap into place and now move together. I repeat this for the other side. Now I add an actuator to control the servo gear. I define it to apply torque to the gear's joint. Finally, I import the bottom plate, which sits underneath the entire structure. Then I test the whole setup by adding a free object that the gripper can pick up. Reload one last time. And that's it. Everything is in place. The gripper works and can pick up the object. Thanks for watching. If you found this helpful, don't forget to subscribe. You can find all the code and files on my GitHub repo linked in the description. See you next time. Bye.